on here can be from grade 6 or 7 material in Ontario or even earlier, but the topics go all the way up to grade 10. So don't worry, it builds a good foundation and then it gets harder, okay? And we're gonna be using this book today. And we're gonna go to page 10 over here because I wanna show you the table of contents, okay? So we're gonna start with the basics. If you wanna play any game in life, you have to know the rules of the game that you're playing if you wanna do well in the game. So we're gonna talk about some basic rules, things like order of operations and the commutative property of addition and multiplication and the associative property of addition and multiplication. Don't worry, if you don't know what that means, it's going to be really easy and you're going to sound so professional once you use the proper term for something that I bet you probably already know. And we may get into the distributive property and factoring, and hopefully we'll see how far we get. We might get into solving some equations, okay? Now I'm going to go at your pace today. So if you have any questions, just let me know. I can slow down, or if I'm going too slow, let me know and I can speed up. So the first thing that we're going to do is order of operations, okay? And we're going to skip to all the way to page 20. I'm looking, by the way, if you want to know where I'm looking up here for page 20, okay? And what I want to tell you is that here are the rules for the order of operations. And does anybody know what we call, there's a mnemonic device that we use that's common in Ontario for how to remember what to do first when we're given a problem. Does anybody know what it means? Know of the mnemonic device? And by the way, I'm not sure if we're recording right now. So let me just stop sharing for 1 second. Yes, we are recording. That's great. Okay. So anybody know? Excellent, Aaron. That's it. BEDMAS. Very good. And who knows what BEDMAS stands for? And I'm going to write it like this, going down. Whoops, messy, right? What does the B stand for? Aaron, you're fast today. Yes, brackets. And then somebody else. Ruby, do you know what the E stands for? If you don't, that's okay. Michael? Alan?
Exponent.
Excellent. Yes, the E is for exponents. And what about the D and the M? Somebody different. Anybody want to, you could also put it in the chat or you can unmute yourself. Ruby, was that you raising your hand? So go ahead, Ruby.
Is it division?
Excellent, yes. D is for division. And Jasmine, do you know what the M is for? Or Crystal? Anybody else? Sorry, say that again. It was hard to hear.
Multiplication.
Excellent. Yes, multiplication. Now, does this mean that you always have to do division before multiplication? Anybody want to clarify that one? Take a look at number 3 over here as a hint. Good guess, good try. So you'd think that, hey, the D comes before the M in BEDMAS. You'd think, well, I have to do division before multiplication, but not necessarily. They're equal. So you just do them according to the order in which they appear. You do them from left to right. So if division happens before multiplication, left to right, you do division first. But if multiplication happens first, when you're reading it from left to right, then you do multiplication first. So these two are equal, okay? Whichever happens first when you're reading it from left to right. And then what about the last two? What do the A and the S stand for? Anybody? You could write it in the chat, or you could, well, you could try to raise your hand, except it's hard for me to see you when I'm sharing my screen. Excellent, Alan and Jasmine and Aaron. and Michael, and very good, and Jasmine. Yes, addition and subtraction. Now, what about for these two? Does that mean you have to do addition before subtraction because the A comes before S? Is that what it means? You have to do addition all the time first? Very good, Alan and Michael. Yes, you're correct. They're just like division, exactly, they're equal. Just like division and multiplication, these two are equal too. You read them from left to right, whichever happens first, that's the one you do first. Excellent. So let's warm up with a couple of examples that we're gonna do. Let me just stop annotating so I can move forward. So we're gonna go to this section right here. Here's what we're gonna do. I'm gonna scroll up and I'm going to create a little whiteboard for myself over here so that I can hide the answers and so I can use it like a little mini whiteboard. You'll have to bear with me with my messy mouse handwriting, using my mouse to handwrite, okay? So take a look at A, all right? So if you take a look at A, I want you in the chat to try your best to find out the answer to A and just tell me, is it 72 or is it 30? Is it this, A, or is it B? Tell me which one is the correct answer and why. Let's see. Okay, I love the participation. Okay, so 3 people are saying 30. And let's see. If it was this way, we would do, well, 6 plus 3 times 8. Tell me what I do wrong, okay? 6 plus 3 is 9 times 8. 9 times 8 is 72. What did I do wrong?
You should times the A with the C for first.
Amazing, right? Exactly. Why is that? Why should I do this first?
Because multiplication comes before addition.
Exactly. So if we go back to BEDMAS, order of operations, sorry people, I'm slow with my mouse. Here's multiplication and here's addition. We have to do the multiplication first, even though there's no brackets, okay? So very good. So if we do the 3 times 8 first, then that will give us 6 plus 24, and that's 30. And a lot of you got that correct. Good for you, good job. So let me do another whiteboard to clear this. And I think we probably shouldn't do this one because, actually no, we'll do it right now. Let's do this one next, okay? Now what's the answer? Very good. Very good, Aaron, Michael, and Alan. You know what I'm gonna do, people? I'm gonna set the chat so that only I can see your answers, just in case you're going along with the crowd, okay? And I'm sure that you're all very smart and you all got that by yourself. But as it gets trickier, I just want to make sure that you really understand. That's important to me. Okay, let's do something a little bit more challenging. I'm gonna do C, and you have to tell me if I'm doing it correctly or not, okay? Remember, all of these are about order of operations, or we're using BEDMAS to help us remember the correct order of operations. So I'm gonna do C now. Let me erase this circle over here so this doesn't get confusing to you. This is the one I'm doing right now. And I'm just gonna rewrite the question. And let's see, 17 take away 2 is 15 times 3 squared. And well, 3 squared is 9, so I'm going to do 15 times 9. And trust me, I already did this in the calculator. I'm not that good at mental math, but it's 100. I got 135. Yay, did I do it right?
No. Do the square first.
Very good, excellent, that's right. So there's no brackets, but remember, if we were to write BEDMAS, E is the very next thing. E stands for exponents. So that's what we should have done first. Excellent. So what we should have written is 17 minus 2 times 9. And then, so this is wrong, right? And then we would have gotten 17 minus 18 because we have to do the 2 times 9 first. 2 times 9 is 18. And what is the answer to 17 take away 18? This is a small number subtracting a big number. Oh, you people are so good. Very good. Yeah, it's -1, right? If you had $17, I'm just going to make this money now, but you owed somebody $18, well, you wouldn't be able to pay them all at once, would you? You'd have to give them all your 17 and then you'd still have to owe them $1, wouldn't you? So you not only would you have zero money left, you would have to owe another $1. So that's -1, okay? It's money you don't have yet. All right, you're doing great, everybody. Let's do, I think we could probably jump to the hardest one and then we'll move on, okay? So I hope I'm not going too slow or too fast. So I think we're going to jump to the hardest one in this question, in this problem 1.1. And let me get rid of this circle so it doesn't confuse anybody. And we're going to do this one right here. Lots of good things happening here. Well, I see subtraction and brackets and division and multiplication and exponents. It's a big party in this question, all right? So why don't you, I'm going to rewrite the question and I want you to help me figure out what to do first. You tell me what to do, okay? So first, I'm going to rewrite it in a little slightly different way. I'm still going to put the brackets here, but then this division by 2, I'm going to write it like this. And then notice how there's square brackets around this whole thing. Before the 15 and after the dividing by 2, there's brackets here. Okay, and then I multiply this by 3, and then I subtract 2 squared times 3, and this divided by 6, I'm going to do this. Okay. All right, so does anybody, I'm looking at the chat. I don't just want the final answer. I want to know. And by the way, Ruby, luckily I'm the only one that saw your answer. Ruby, you're correct. Good for you. Okay. So maybe you can help us, Alan, so are you. But everybody tell me, because on a math test for school, I bet if you just wrote the final answer, would your teacher give you full marks? Because I know that when I teach math, I want to see people showing their work, right? Because communication is an important part of math. So tell me, what's some of the first things that I can do? Any ideas? Remember, don't forget to use BEDMAS. What would be the first things? Excellent, Alan. Yes. Any other ideas? Jasmine, Crystal, Ruby, Michael. Very good. Very good, Ruby and Alan. Ruby and Alan have told me the first thing that I can do. Yeah. Any other ideas? Okay, you know what? Thank you very much for telling me that, Jasmine. Really good. Okay, good. So yes, so we're gonna look for, so for the people who haven't learned this yet, and I have a couple people in this class, I don't want to say who they are, but they haven't learned this yet, and there's nothing wrong with that. So B stands for brackets. I'm gonna look for brackets, and look, I have some over here and some over here. Everybody, what's 15 minus 3? Shout it out, unmute yourself.
No.
Exactly, 12. So what I'm gonna do is, I'm gonna just rewrite it, whoops, wrong color. I'm just gonna rewrite it over here. I'm gonna take this out and put 12. Just to keep it nice and clean and neat. Okay. And wait, there's more brackets over here. So now that means we have to zoom in inside the brackets. And when we zoom in and just look at these brackets over here and look at what's inside these brackets, what do we have to do first? Very good. Yes, the 2 times 2 first, because the exponents come before multiplication. So you're right, 2 times 2 is 4, and then 4 times 3 is 12. So just to keep it simple, I'm just going to take this out, and now I'm going to put 12. Excellent. All right, now what do we do? Tell me the operation in here that we would do. The B, E, D, M, A, or S. There's no more brackets, that's done. There's no more exponents, that's done. So what's next? What do we see next here? Very good. Yes, exactly, the division. So because this means 12, it's not just a fraction, 12 over 2 or 12 halves. This line over here also means divided by. So this means 12 divided by 2. And what is 12? Very good. 12 divided by 2 is? Everybody shout it out. 6. Excellent. I love dealing with a class of brilliant mathematicians. So I'm just going to recopy the question so far. But what do I do over here? What do I have here? I have division again. That's right, Michael. Very good. And I'm going to write the answer to this division. 12 divided by 6 is 2. Excellent. Great job, everybody. Now this is pretty simple. Look at the question we started off with, and now look at what we have. Now, what do I do first? Excellent, Aaron. Excellent, Ruby. Excellent, Michael. Excellent, Alan. Very good. We do the multiplication first, not just because it happens first, but because multiplication comes before subtraction. Very good. So that's 18, take away 2. And we all know the answer is... Yay!
16.
Exactly. Good work. And I got a flood of 16s in the chat. Great work, everybody. Okay, so I think you demonstrated your knowledge of order of operations very well. So I'm going to clear all this. And now we're going to move on. We're going to move on to something called the commutative property of addition. Okay, so we're going to go to page 22. Oh, there's more, by the way. There's more. Actually, you know what? There's more questions right here on order of operations. Let me see in the chat. If you think something like E or F looks a little scary to you, then I want to do it right now and practice it with you. Or do you think it's just too easy? Then we can move on, okay? So tell me what you think. Do you want to do something like F right over here? This one here? Whoops. Okay, a couple of people are saying it's too easy, but maybe you have to prove it. Tell me the answer really quick. Okay, how about this? What's the first thing that we do? If we're following BEDMAS, what's the first thing we do? Like, in other words, multiplication, division, exponents, what do we do first? Very good, Ruby. Very good. So we do have to look at the brackets, and then inside the brackets, we zoom in, and then we look at just what's in the brackets. And there we have exponents and subtraction. So we're just going to do the exponents first. So 2 squared, or 2 to the exponent 2 is 4. 4 take away 3 is 1. So now this becomes 11 times 6 to the exponent 1. Well, what is 6 to the exponent 1? That's right, everybody. It's just 6, right? So it means 11 times 6. And like everybody said before, the answer is 66. Good job, people. Okay, excuse me. My nose is a little bit itchy. 1 second. Thank you for your patience. All right. So now we're going to learn about something called the commutative property of addition. And maybe it sounds really fancy to you, but you'll see it's pretty easy. So let's read problem 1.2 together, okay? And I want to hide, just so that you're not distracted, I am going to hide the rest of this here so you can just focus on problem 1.2, okay? Josie has 14 marbles and Beth has 8 marbles. Josie counts all the marbles by starting with hers and then adding Beth's. Beth counts all the marbles by starting with hers and then adding Josie's. If they add correctly, will Josie and Beth find the same number of marbles? Very good. Okay. So, exactly. Yes. So, if we do it Josie's way, I'm just going to put a J for Josie, okay? Josie starts with 14 and adds 8 Beth's, right? And what is that? That is 22 marbles. But if we do it Beth's way, Beth starts with her marbles. She has 8, and then she adds on Josie's. And look, she gets the same answer. Very good. Now, what do you think the commutative property of addition means? Rather than me telling you the fancy definition or explaining what that means, let's see if you can tell me, and I'm going to type it so that you don't have to deal with my handwriting, the commutative property of addition. Let me just widen that. What does that mean? If this problem 1.2 is an example of the commutative property of addition, what do you think it means? Does anybody want to unmute themselves, or do you want to put it in the chat? Go ahead, Ruby.
I think it means like it doesn't matter the order of like how you're adding those numbers doesn't matter.
Exactly. Brilliant. That's exactly it. When you're adding 2 numbers, the order doesn't matter. Excellent job. Good work. So let me clear all that and let me show you, where is this commutative property? It's on page 22, but I wanted to find you the official definition. There it is, right here, people. Let me show it to you. See this right over here? Addition is commutative, which means we can reverse the order of 2 numbers being added without changing their sum. Now remember, a sum is the answer when you add something together. When you add 2 things together, the answer is called a sum. So in other words, if you add any 2 numbers, we're going to call them A and B. A could be any number, B could be any number. Whether you add the A first, followed by the B, or whether you start with the B and then add the A, the order doesn't matter. By the way, what do we call these letters A and B? They have a special name. Does anybody know when we, yes, very good, Aaron. They are used in algebra, okay? But they have a different name. So whenever we want to use a letter to represent a number that can change, a number that can vary, hint, hint, hint. What do we call that? So close, Aaron. So whenever we get a letter or something that can vary, any number, and the number can vary, we call those letters something. You got it, Aaron. You got it. Let's see if anybody else gets it. It's okay. I don't want to wait too long, so I'm just going to tell you. And good job, Aaron. They're called variables. Very good, because they can vary. A could be anything. B could be anything, right? So good job, everybody. So that was the commutative property of addition. So now where did I want to go to next? I wanted to go to page 24. I wanted to do, yes, I wanted to do this problem now, okay? And I'm going to hide the solution. Don't read ahead fast. Thank you for letting me know, Jasmine. Okay, so Joe and Renee are counting the tiles on their deck. Their deck is shown below. Joe says that there are 6 columns. So I'm going to show you how I'm going to show you in different colors. So Joe says that there are 6 columns, 1, 2, 3, 4, 5, 6. Remember, columns are vertical, up and down. And they have 4 tiles each, 1, 2, 3, 4, okay? So he says that there are 6 times 4 tiles. That's what Joe says, right? But Renee, I'm going to use a different color now. Renee says, oh, maybe I'll use green. Renee says that there are 4 rows. 1, 2, 3, 4 rows with 6 tiles each. 1, 2, 3, 4, 5, 6. So she says, so Renee says that there are, 4 rows with 6 tiles each, that there are 4 times 6 tiles. Who is correct? Very good, Michael. Very good, Aaron. Anybody else? Very good, Alan. Jasmine is gonna be, hold on, right back. Crystal, any ideas? Ruby, any ideas? If you're shy, you could just put it in the chat because nobody else can see, just I can see your answer. Very good, Ruby. Crystal, you want to, very good. Very good. Okay, that's right. And so where did we use this before, where the order doesn't matter? We were talking about it with addition, right? When the order doesn't matter in addition, what did we call that property? Who remembers what that property is called? Starts with the C.
Commutative property.
Yes, that's amazing. Good work. Yes. So just like the order didn't matter when we were adding, it's also, thank you, Jasmine, for letting me know. It's also called the commutative property of multiplication. Because remember, multiplication is just repeated addition. For example, when we were doing the 6 columns, instead of adding 4 plus 4 plus 4 plus 4 plus 4 plus 4 6 times, we can just say 6 times 4 or 4 times 6, right? So multiplication is just repeated addition. So if addition is commutative, so is multiplication. So there's the commutative property of addition, and there's also the commutative property of multiplication. In other words, the order doesn't matter. Good job. Jasmine, did you miss anything important? Just something really quick. We can summarize it. And where is it? It's right here. I'll show you where it is. Watch my spotlight over here. We just went through an example that shows that multiplication is commutative. In other words, when you're multiplying, the order doesn't matter. Whether you say 6 times 4 or 4 times 6, you get the same answer. Does that make sense, Jasmine?
Yeah.
Amazing. Thank you for your cooperation. Oh, Aaron, I thought you were saying no, it doesn't make sense, but you're already answering the next one. Okay, amazing. How did you know? You're psychic. I was gonna have you do problem 1.4, but everybody close your eyes because I'm gonna put a little whiteboard here, okay? Don't look at the answers, don't look at the answers. Okay, whoops, what happened? It's not, oh, I chose the wrong shape. Look at that. Okay, that's better. Okay, so now Maybe you did look at the answers, maybe you didn't, but you still have to explain how you know, okay? All right, so A. Is A true or false? Very good, Alan. Very good, Ruby. Very good, Michael. Very good, Jasmine. Let's see. A couple people still missing. So what's 2 minus 5, everybody? What's 2 minus 5? Very good, Crystal. That's right. 2 minus 5 is -3. I'm just looking at the chat. Excellent participation. What's 5 minus 2? 3. Very good. Is -3 the same as 3? Nope, definitely not. Okay. So what do you notice? Is subtraction commutative? Let me write that down as a proper sentence. Is subtraction commutative? In other words, addition was commutative. Is subtraction commutative? Very good. Yes, subtraction is not commutative. Okay, very good. So now let me get rid of this. Clean it up. Now, what about B? What's the answer to B? Is B true or false? Very good, everybody. Very good. Yes. Okay, so we're adding 2 and -5, and then we're adding -5 and 2. We're still adding 2 numbers. So as long as you keep maintain whether a number is positive or negative, if you don't change the sign, if something started as positive, you keep it as a positive number. If something is negative, you keep it as a negative number. If you do that, then if you're still adding numbers, even if they're negative numbers, if you're still adding them, you're right. The order doesn't matter. Very good. Okay. So B is true. Now let's look at C. The first part of C means 8 divided by 4, right? That means 8 divided by 4. So I'm rewriting this in 2 separate ways, like this and like this. They mean the same thing. So what's the answer to 8 divided by 4? Very good, Michael. You already have the answer. Very good, Aaron. Yeah, the answer is 2. Excellent. Now I'm going to rewrite this one. I'm going to write it like this: 4 divided by 8 or 4 divided by 8. What's the answer to that? Very good. Very good, Alan. Good try, Michael. Okay, let me explain it this way, okay? In the first problem, we have 8 pizzas. We got a big party. We got 8 pizzas. And we have 4 people. How much pizza does each person get? 2 whole pizzas each, right? 2 pizzas per person. That's a lot of pizza. You better be hungry, right? But in this second problem, we've got 4 pizzas. I hope you like the way I make my Zs. I like making my Zs like that. But we have 8 people. Okay, 4 pizzas, but 8 people, twice the number of people. Is everybody going to get a whole pizza to themselves? So close, Ruby. Okay, imagine this, people. You've got 4 pizzas. Watch this. Hold on. 1, 2, 3, 4 pizzas. Sorry, they're not the same size. I'm trying to do this quick, okay? And you got 8 people. What are you going to do? How are you going to solve this problem? How much? Very good, Ruby. You caught your mistake. That's it. You got it. So how are you going to figure out how much pizza does each person get? That's right. Everybody gets half a pizza, right? Half a pizza. So 4 divided by 8 is half. Every person gets half a pizza. Now we've got 1, 2, 3, 4, 5, 6, 7, 8, and enough for all 8 people, right? Very good. So good work there. The answer is half. So whether you read it like this or whether you read it like this, 0.5 and half is the same number because 1 divided by 2 is 0.5. Good stuff. So 2 pizzas a person versus half a pizza a person is a lot. It's a big difference in pizza, right? Okay. So it's not the same answer. You're right. So let me ask you this, and let me clean up the area so that nobody's confused. And let me start typing. Okay. Whoops, there we go. Is subtraction, whoops, not subtraction, we were doing division. Is division commutative? In other words, when we're dividing, does the order matter? Oh, well, you know what? I didn't ask it in a very clear way. I said, does the order matter? And someone said, yes, the order does matter. But maybe if I ask it, is it commutative? Remember, if it's commutative, it means the order doesn't matter. So is it commutative? Is division commutative? Very good, Ruby. You're so precise, Ruby. Very good, Michael. Very good, Aaron. Exactly. Division is not commutative. So that means the order does matter. Excellent work, okay? Let's do D really quickly. I just want to do a quick yes or no, why or why not, and then we're going to move on, okay? Oh my gosh, look, it's 5:40 already. Time flies when you're having fun. So what about D? Is it true or false? Does 8 times 1/4 also equal 1/4 times 8? Good work, Michael, Aaron, Alan, Ruby, very good. Anybody else? Very good, Ruby. Yes, excellent work. Yeah, it is true because very good. And as Ruby said in the chat, multiplication is commutative. So when you multiply and when you add, the order doesn't matter. When you subtract and when you divide, the order does matter. Okay, good work, everybody. All right, what page did I want to go on to next? I wanted to go on to the associative property of addition and multiplication. So again, it's going to be a term that might sound fancy, but you're going to see, no big deal. So we're going to go to page 26, problem 1.5. Let me see. Problem 1.5. Ah, yes, there it is. So don't look at the answer. Don't look at the answer. I'm going to hide it. Hopefully that was too fast for you, okay? So people, I don't follow football. I'm not a sports person, but don't worry. This is a pretty easy question, even if you have no clue about how football works, okay? So in American football, a touchdown, I'm gonna write this down, okay? Or maybe do I have to? A touchdown is worth, how many points? 7 points. 7 points, okay? And a field goal, it's one strategy when you're problem solving is to rewrite the given information. So I'm just modeling that for you, all right? Field goal is worth 3 points. Well, I guess I don't have to write the word points right now. And safety, I don't even know what a safety is, people, but don't worry, you don't have to know what a safety is. Whatever a safety is, it's worth 2 points, okay? Now, first quarter of a game, the first part of a game between the Eagles and the Cowboys. The Eagles, and let me space the Eagles, and then the Cowboys. I'm gonna handwrite the rest, okay? The Eagles and the Cowboys. Uh-oh, there's something that I forgot to hide over here. Don't look at that, okay? There we go. Let's see here. in the first quarter of a game between the Eagles and the Cowboys, the Eagles score a field goal, then score a touchdown. So how many points is that, people, if the Eagles score a field goal and then a touchdown? Everybody? Amazing, amazing, good, that's right. So they scored, field goal is 3 points, whoops, 3 points, but then they scored a touchdown, so they got 10 points in the first quarter for the Eagles, okay? And then the Cowboys only score a field goal. So how many points did they get? They only got 3, okay? So I'm gonna call this, maybe I'll call this, instead of over here, I'll skip that. I'm gonna call this first quarter, now I'm gonna do second quarter, okay? So we already answered A. How many points does each team score in the first quarter? We did that. Now we're gonna do the second quarter, okay? Let's see here. In the second quarter of the game, the Cowboys score a touchdown and a safety. How many points is that? The Cowboys score a touchdown, that's 7, and a safety, that's 2. So that's 9, right? Very good. And the Eagles only score a safety, and the safety is 2, okay? So we figured out B, but now C is asking who's winning at the end of the second quarter. So how many points total do they have? So the total, it's a tie, very good, okay? So the total is, we have, 10 plus 2 is 12 for the Eagles. And we have 3 plus 9 is 12 for the Cowboys. But what this example is trying to show you is something called the associative property. In other words, if you take a look at what we did 3 plus 7 plus, whoops, this is really messy. Let me redo this, okay? I'm gonna run out of room. So we did 3 plus 7. We did that first because it was in the first quarter. And then we added the 2. That was for the Eagles.